Alright, hi guys. So it's our first online tutorial with me using my actual software, so pretty exciting. I know you're very excited about it. Alright, so we're starting with properties of quadrilaterals. Today in class we did the properties of quadrilaterals just in terms of parallel lines and focusing on sides and angles, just sides. So tonight we're going to be looking at the diagonals and the angles and what the different properties of that are going to be. And we're just going to go through each shape one by one. So this is going to be really content heavy and somewhat of a pain to copy all this down. But it'll be good to get this out of the way so that we can work with this tomorrow. So the first thing we know about parallelograms, obviously, are that our opposite sides are parallel. Which means that we can draw our tick marks for our opposite sides being parallel. Right? Next, from this, we also know that opposite sides are congruent. Okay, so there's our congruencies as well. Okay. Now, getting into angles, parallelograms, we discussed this a little bit before, but our opposite angles are congruent. Right? So, opposite across the figure, opposite angles are congruent. Okay. Now, a property of the diagonal. Right? Our diagonals actually bisect each other. So I'm going to try and draw this with a dotted line. And there's my diagonal and my other diagonal. Right? And these diagonals are bisectors of each other. So one diagonal cuts the other into two congruent parts. This diagonal cuts the diagonal into two congruent parts. So the diagonals bisect each other, or they're both segment bisectors of each other. Let's see. Diagonal are bisectors of each other. And last but not least, since we are dealing with parallel lines, we get a final property that any pair of consecutive interior angles, right, so a pair of consecutive interior angles, right, is congruent. Any pair of consecutive interior angles is, supplementary. Supplementary, or equal to 180. Right? So again, this is using the fact that when we had our parallel lines and transversals, those consecutive interior angles were also, now we just have one more transversal giving us this parallelogram shape. So you can use that property. Right? So there are all of the properties for parallelograms. Now let's go on to rectangles. Right? Rectangles. All of the properties of parallelograms apply since a rectangle is a parallelogram. Okay? So all properties of parallelograms apply. Right? In addition to that, we get the properties that we already discussed today. All angles and right angles. So there's our tick mark. Right? And we get a special property for rectangles, right, that the diagonals are congruent. So here our diagonals are congruent. So there's our diagonal, right? So because the property of a parallelogram applies, that does still mean that the diagonals are bisecting each other, right? But they happen to be congruent, so now all of our bisected pieces are going to be congruent to each other. So we do have a few other things to consider with our rectangles, but really the only additional thing. Okay, sorry, someone was being rude and interrupting. All of the parts of the parallelograms also apply. Okay, so now we move on to rhombus. Right, so we're sticking within those pairs of, or those shapes that have two pairs of parallel lines. Okay, so yes, a rhombus is a parallelogram, so all of our properties, all properties of parallelograms still apply. Right, and now we have an interesting combination of new properties just for the rhombus. Okay, so yes, we've already talked that all sides are congruent. So congruent, 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 congruent. We knew this from today, right? The diagonals. Right? So our diagonals have this special relationship that they form perpendicular angles. Oops, that's messy. Alright. Can't get this to work. There, that's a 90-degree angle, you can tell, okay? So, diagonals, alright, are perpendicular. So there's a lot of interesting applications that will come in handy. Okay. Diagonals also bisect the angles of the shape. Or diagonals bisect the angles. Okay. So what that means is this is congruent to this. And since we know that all of the properties of parallelograms apply, we also know that opposite angles are congruent. So this opposite angle is congruent to this opposite angle. And this diagonal is also bisecting that. So our angles are being bisected and they're also congruent to each other. Right? Diagonals are perpendicular bisectors of each other. Okay? So that just combines two of our properties. Yes, we know that diagonals bisect each other in parallelograms, so these are bisecting each other, and they're meeting at a perpendicular, so we say they're perpendicular bisectors, which you could come up with on your own just by knowing that they meet at a 90-degree angle and they're everything that a parallelogram is. Right? And the special thing about our rhombus is that our diagonal cuts the rhombus into 4 congruent right triangles. Right? So if all of these angles are right, all of these sides are congruent, these are bisected. Using our triangle congruencies, we can prove that all of these triangles are congruent. Right? And we will get to some of that tomorrow. But for now, it's enough to just know that they are, and then we'll kind of get into how we can use that later on. Okay? Moving on. Squares. Right? So now, squares, because squares are at the very bottom of these parallelogram categories, we can say that all properties of a rectangle and a rhombus apply. Right? all properties of a rectangle and a rhombus apply. And since all the properties of a parallelogram apply to a rectangle and a rhombus, technically, all properties of a rectangle, a rhombus, and a parallelogram apply to squares, but we can get that through the properties of the rectangle. Okay? So the only special property here that we're adding on top of all the properties we've just discussed is that, yes, in a rhombus, they created, or the diagonals created 4 congruent triangles, right? In a square, we still get 4 congruent triangles, and our diagonals are meeting at right angles, they're bisecting. Okay, so the 4 congruent triangles that we're getting are 4 isosceles 45, 45, 90 triangles. 4 isosceles triangles. Okay? Because the diagonal is bisecting the angle, we know that the angle is a 90-degree angle. And so therefore we have a 45, 45, 90 triangle, and we have 4 of them. They're isosceles triangles because the diagonals are bisecting each other. Since the diagonals happen to be congruent and they're bisecting each other, then the bisected pieces are also congruent. Alright, so a lot to handle, right, but we will be discussing this tomorrow. Right? We're going to get to kites and isosceles triangles tomorrow in class, just to not overwhelm you. So for right now, we're just focusing on the shapes that have 2 pairs of parallel sides in our quadrilateral. All right, good luck.